Hello there, Mr. Sutton here, bringing you the AB Calculus 2-6 Extra Practice number 7 solutions on continuity. There's a puzzle that goes with this. Let's check that out. So for the first 28 questions, we're using that table on the worksheet to come up with the question. What I've essentially done on all of these is taken what was in the table and translated it into something that they're actually asking for, which is what this f of -3 business is up here. So first thing, we're looking to find f of -3, and then we'll also figure out the limits at -3. So f of -3, that's where the graph actually is at -3 for the x value. So that's right here. We have to use the solid dot to identify that spot, and the y value at that solid spot is going to be a -1. So -1 is this answer. That corresponds with L over here in the answer column, which I just moved over to the left to get it out of the way. So L is going in spot 1, which is right there. For question 2, we're asking for the left side limit at -3. So as I approach the x value -3 from the left side, like so, the y value I'm heading towards from that side is -2. So that is our left side limit. And then -2 goes with letter N, so that's going in spot 2 right here. For number 3, we want the right-sided limit at -3. So back to -3. Now we're coming from the right side. As we approach from the right side, we're heading toward the y value -1. So -1 is that limit, and -1 again is L. So L is going in 3. For the two-sided limit at -3, we notice that we're going to a different place as we approach from the left and the right. From the left, we're going to -2. From the right, we're going to -1. So since those don't match up, this would mean, since these are not the same limit, that we have DNE, does not exist, none for the limit. So that's choice T right here, going in spot 4. Next up, the next 4 questions are all about the x value -2. We're just going kind of predictably from left to right at different x values. So f of -2, that's the solid dot if there is one at -2. We see here that there is an open dot there, but nothing solid. So this is a DNE, does not exist, none. That's T again, going in spot 5 right here. Now for number 6, we want the left side limit at -2. So at -2, x equals -2, as I come from the left side, I'm approaching the y value, well, this looks to be about -1/2, -1/2. So -0.5 is what I'm going to actually equate that to here. That's going to be an E going in spot 6, which is all the way at the end over here. For the next question, we want the right side limit at -2. So as I come from the right side, like so, I'm heading toward the y value -1/2 again, same as the left side limit. So again, -0.5, that's going to be E going in spot 7 all the way over here. For number 8, we want the two-sided limit at -2. So as we go back to the x value -2 from the left and the right side, we're approaching the same place, -0.5 or -1/2. So we are again choosing choice E, and this time it is going in spot number 8, which is right here. For number 9, and also the questions up through 12, we're looking at -1 now. First off, we have f of -1. That corresponds with the solid dot right here at the x value -1. And in terms of y values, that dot looks to be at about 1/2 or 0.5. So D then is going to go in spot 9. That's right here. Now for the left-sided limit at -1. We're at -1. As we come from the left side, we are approaching the y value 0 right here. That's right on the x-axis. So 0 is our left-sided limit. 0 corresponds with H over here in our answer columns. So that means 10 is going to be an H. And where is 10? Right here. Now we're doing -1 from the right side. So here's -1 coming from the right side. It looks like we're approaching the y value +1. And 1 corresponds with I, so we have 11 being I. For the two-sided limit at -1, we look at the left and the right-sided limits. From the left, we're approaching 0. From the right side, we're approaching y equals 1. Since those are not the same limit, this is DNE. So that would be none. Choice T going in spot 12. And where is 12? Right here. For the next 4 questions, now we're moving on to the number 0, starting with f of 0. So that's the solid dot right here at x equals 0. That's at 1/2 or 0.5. So we're putting a D in 13. And 13 is going to be, where is it? Right here. I feel like half the time on this is spent just looking for the number. For 14, we want left-sided limit at 0. So we're at 0. We're coming from the left side. As we come from the left side, we're going up to infinity there, if that's even a thing. So infinity for this limit, and infinity, positive infinity, goes with O right here. So that's going to be 14 over here. For the right-sided limit at 0, coming from the right side, as we head towards 0, we are going down forever. So that's negative infinity, which goes with U, and U is going to go in spot 15, which is right here. For the two-sided limit at 0, from the left side, we're going to positive infinity. Right side's going to negative infinity. Since those limits are not going to the same place, not even the same infinity, we would say that this does not exist. So T, none, and that goes in spot 16, which is going to be right over here. For f of 1, we're looking for where the graph is at x equals 1. That's right here. The graph is solid, and it's on the x-axis at 0. So 0 goes with h. That's going in spot 17 right here. For number 18, left side limit at 1. As we get towards 1 from the left side, we're heading towards 0. So again, we're putting an h in that spot. That's going in 18 down here. The right-sided limit at 1, as we come to 1 from the right side, we're heading towards 0 as well. So that's again h, going in spot 19 this time, right here. Lots of h's. For the two-sided limit at x equals 1, since from the left side and the right side we're heading to the same place, we're going to just report what that place is, which is still 0. So now we have another h. This is our 4th one in a row. This is going in spot 20. Boy, who knew there were so many h's here? For f of 2, this is right here. Looks like we've got a vertical asymptote there, so that would be undefined for the actual function value. So that would be t, none, going in spot 21 right here. For the left-sided limit at 2, as we approach 2 from the left side, we're going up forever, positive infinity. That goes with O, going in spot 22 right here. For the right-sided limit at 2, as we come from the right side towards x equals 2, we're going up forever, positive infinity. So that's another O, this time going in spot 23, which is all the way over here. For the two-sided limit at 2, from the left side and the right side, we're heading towards positive infinity. So you could say that this is none because the limit technically doesn't exist, but if you are able to give a more specific answer like an infinity, it's generally suggested that you do so. Since these are going to the same infinity, we can also call this positive infinity for that limit, which means we're putting another O on there, going in spot 24, which is right here. Now we're on to our last batch of numbers that we're doing the same things for. So f of 3, function value at x equals 3, there's an open dot there and nothing else, so that's DNE, does not exist, none. So we have t going in spot 25, which is right here. Left-sided limit at 3, from the left side we're approaching negative 3, so there's our limit. That's going to go with A, haven't seen one of those yet. So 26 is A. The right-sided limit at x equals 3, as we come from the right side, we are again approaching negative 3. So that's A again, going in 27. The two-sided limit at 3, from the left and the right side, we're approaching -3 from both directions, so that's our two-sided limit. So A one more time in 28. The next question is asking what the right-sided limit at x equals -5 is. So here's -5. Coming from the right side, we are at the y value rather, -2. So -2 corresponds with n. That's going in spot 29, which is right here. For number 30, we're asking for the left-sided limit at x equals +5. So over at +5, as I come from the left side, we are at -2 for the y value there. So that's n, going in spot 30, which is right here. For 31, we want to know for what integer value in the table is f of x continuous. So continuous means that the limit exists, the function value exists, and the limit and function value are equal. So we're trying to find basically a place where there's no breaks in the graph, where the graph's approaching the same place from the left and right, and there's a solid dot there agreeing with all of that. So definitely not at -3. -4 is fine, but that's not one of our options. So moving forward, -2 has a discontinuity, so does -1. 0's got an asymptote. 1 looks to be continuous, no issues there. 2's got issues with that asymptote. 3's got a hole. So it looks like 1 is our answer, because the limit as we approach 1 from the left and the right equals the function value there. So x equals 1 then, which is I, going in spot 31. For number 32, they're saying f of x has a removable discontinuity or hole when the x value is 3, which we see right here, and when the x value is what? So we're looking for another hole in the graph. The other hole is happening here at -2. So to be a hole, you have to be approaching the same place from the left and the right and just have a hole there. -3 would be a jump, also a jump at -1, an asymptote here at 0 and 2, so we have just a hole at -2. So -2 goes with n, and that's in spot 32, which is right here in the beginning. For 33, they're saying f of x is not defined at the vertical asymptote x equals what? So there's actually two vertical asymptotes, one at 0 and one at 2. For the one at 0, though, f of x is actually defined. It's 1/2. It's this solid dot right here. However, at 2, there's no solid anything to help us out at the asymptote. So x equals 2 is the asymptote that they're talking about here. 2 corresponds with r, which is going in spot 33 over here. For 34, the last question, they want to know how many discontinuities do we have on the interval from -5 to +5. So just going from left to right, we see that there is a jump at -3, and also while we're talking about jumps, we have a jump at -1 as well. We have a hole at -2 and 3. We talked about those earlier, so that's a removable. And we have asymptotes at 0 and 2. And it looks like those are the only problems. I mean, there's lots of, that's a lot of problems, but that's it. So there's 6 of those, which means 6 is our answer. That's going with M, and that is spot 34 here. So now we're ready to solve the riddle. What did the asymptote say to the removable discontinuity? Don't hand that holier-than-thou line to me. I get it. Till next time, Mr. Sutton signing off.